All right, guys, are there any questions on any of the assignments or assignment thus far? Because we've only had one. All right, so where we finished yesterday was with this problem here. And so we're going to start off with this one here. So multiplying it and simplifying it down. Now, when we look at this one here, we're going to want to factor each of these different polynomial expressions in the numerator and denominator of these rational expressions first. And that'll help us when after we multiply to be able to get it in simplest form so that we don't have to multiply and then factor when it gets bigger. Now, looking at all four of these spots here, well, 5x is already as simplified as it gets because it's only one term. There's no way for us to factor it down or get it any simpler. Now, the next one I would look at is the 5x minus 5x squared. There are only two terms, but there is a greatest common factor between them, which is 5x, because we can factor 5x out of both terms. And if we do this, well, the 5x squared here would end up being what? Negative x, yes? Now, we saw this at the end of the class yesterday, but also, whenever we factor any of these here, the value of x for all the rest of these is going to be what? Positive, yes? Well, if we know that this is still going to leave us with a negative x, we might as well not only just factor out the 5x, but also factor out the what? The negative with it. Because in all of these here, when we're working with them, if we can keep the variables positive, the biggest variable in each expression positive, it's going to help us out. And whenever we factor the 5x out of these two terms here, if we factor out the negative, it will keep the exponent with the biggest, not the exponent, the variable with the biggest exponent positive. So let's look at how this factors out. If I factor a 5x out of the 5x here, I'm left with 1, because the 5 will factor out completely, the x will factor out completely. But unlike yesterday, this time we're factoring out a negative 5x. So instead of it being positive 1, it's going to be negative. Because since it was positive to begin with and we factor out a negative, it's going to become negative. Now for the next one, negative 5x squared. Well, we factor the negative out, which is going to make it positive. The 5 factors out completely. And we take 1x away from x squared, which leaves us with an x. Now we are going to flip this around, but I didn't want to do that all in one step. Because pulling out that negative 5x is going to leave us with x minus 1. We have it written as negative 1 plus x. But that's fine. We will flip the 2 here in a minute. But that's more helpful to us than having 1 minus x. Yes? Because that'll match up better. We don't have to factor out the negative later. Now let's look at the rest of these. So we need to factor the x squared minus 4x plus 3 and the x squared minus 5x plus 6. Which one do we want to do first? Well, let's go on and do the x squared minus 4x plus 3. Since the third term, the 3 is positive, the signs are the same, and they're going to match the sign of the middle term, which is negative. So we'll have negative and negative. Now we need to find the factors of x squared, which are x and we also need to find the factors of 3, which is, well, 3 and 1 or 1 and 3. We only have one set of factors. We could have written it either way. We could have had x minus 1 times x minus 3, as we have here, or we could have also had it as x minus 3 times x minus 1. Either way is perfectly fine. Let's look at the numerator, x squared minus 5x plus 6. Since the third term is positive, the signs are the same, and they match the sign of the middle term, which is negative. So we have negative and negative. Now the factors of x squared are, well, x and x. And the factors of 6. Well, we have 1 and 6 or 2 and 3. Which one do we want to use? 2 and 3. Now we do have an x minus 1 on bottom and an x minus 3, so either could work, but let's check to make sure that this one is the one we want. X times negative 3 would be negative 3x. Negative 2 times x is negative 2x. Negative 3x minus 2x is a negative 5x, which is exactly what we wanted. So we have everything factored, and we can multiply it together. So on top, we'll have the negative 5x times x minus 1 times x minus 2 times x minus 3. On bottom, we'll have the 5x times x minus 1 and x minus 3. What simplifies on top and bottom? X minus 1 and x minus 1. X minus 3, and then 5x and the 5x. Now, if we notice, everything in the denominator did simplify out completely. So we don't have to put a denominator. But in the numerator, what do we have left? And the negative 1. The negative is still there. Because the 5x, the negative 5x and 5x, only the 5x simplified out. The negative is still there. The only way the negative would simplify out is if we had a negative in the denominator. Any questions on this here? All right. Let's look at this one here. Now, if we look at this one, as we look at this one here, there are a few parts of it that actually don't factor or have factors because they're already in simplest form. What parts of this expression won't factor any further than what it is? The x plus 3, because we do have two terms there. There's not a greatest common factor between them, and the degree is 1. So we know it's a simplified form. Where else? 2x squared, because that's only one term. Can't really factor if we only have a term. So that does leave us with the 2x squared minus 10x and x squared minus 25. We can start off with the 2x squared minus 10x. What can we do first? There is a greatest common factor of 2x that we can factor out. If I factor 2x out of 2x squared, I'm left with 1x minus, because we didn't pull out any negatives, we didn't mess with the sign, so it would still be minus. If I factor 2 out of 10, I'm left with 5, and the x factors out completely. So we're left with 2x times x minus 5. And that brings us to the last piece to factor, the x squared minus 25, which is a difference of perfect squares, which would factor to x plus 5 and x minus 5. Now we multiply it together, we'd have 2x times x minus 5 times x plus 3. On bottom, we would have 2x squared times x plus 5 times x minus 5. Now what's in common on top and bottom? The x minus 5 and x minus 5, yes? So the 2x, I can say yes. The 2 will cancel out completely. What's going to happen to the x's? Because I have 1 on top and 2 on bottom, so one of them will cancel out, leaving me with 1 left over. When I do these here, I'll just cancel out the ones and reduce it, because I knew one of the x's would reduce on top and bottom, so I reduced the x squared to 1, because 2 minus 1 is 1, bigger on bottom, so it stays on bottom. If it had been 4 left over, I would have rewritten the number 5 or whatever it is with a 4, or whatever's left there, just so I'm not having to rewrite the whole thing over again for one of these just simplifying. Is anything else in common? Well, no. So what do we have left? On top we have, do we have anything else left besides the x plus 3 on top? I mean, we do have things on bottom, but not on top. Since it's the only thing that's left, I don't have to write the parentheses around it. We can do it. There's nothing wrong with including them. But if it's the only thing left, we can leave them out. On bottom, we're going to have what? Times x plus 5. And this would be it here. Now, this will be one of the few ones we'll talk about the restrictions with, because we didn't talk about it in the last one. But again, the restrictions are going to be whatever is going to cause the denominator to be 0. So looking at this here, what value of x is going to make x equal 0? So we would have negative 5, yes? Because that would make x minus 5 0, yes? What would make x be 0? Zero. Because is there anything else with the x? No, so it would be 0. Now, there's only one other restriction that we haven't talked about, which is the x minus 5, yes? And what value of x would make it be 0? Positive 5, yes? Because 5 minus 5 would be 0. 5. Now, the x squared is just still going to be 0. Now, I'm not going to make you list the restrictions on the homework, because if you do look at the back of the book to check your answers on some of them, they will have the restrictions listed. And for this one here, they would have that x is not equal to 5. They won't have the negative 5 or 0. Now, the reason that they do that is because, well, these two restrictions here are still listed in our answer, yes? So they don't list them because they're still there and we can see them. Is, I think, essentially the reasoning they have for it. Personally, and kind of coming just from a pure mathematical standpoint, I would still list them all. Even if they're still there, they are still restrictions. So if we had to, the book would just list the x is not equal to 5, but really all the restrictions are 0, negative 5, and positive 5. Any other questions on this here? All right, let's look at the next one. C cubed plus 8 over c to the 5th minus 4c cubed times c to the 6th minus 4c to the 5th plus 4c to the 4th divided by c squared minus 2c plus 4. Well, this might look like a whole lot, but let's take it one step at a time, and it actually won't be as bad as you might think. Well, let's start off with c cubed plus 8. Well, this here most likely is a sum of perfect cubes. Can we take the cubed root of c to the third? Well, yes, it would be. And the cubed root of 8 is 2. So this here is the sum of perfect cubes. And we can factor it out as such. We'd have our two sets of parentheses. The first one would be our one with 3 spaces. And the second one would be the one with 5. And for the sum and difference of perfect cubes, our signs would be the same, opposite, always end on a positive note. So to match it, we would have plus, minus for opposite, and always end on a positive note. So plus, minus, plus. Our first set of terms would be with c, so we'd have c. In the first spot, we'll have c squared, then we'll have c, and then c to the 0. In the second set of places, we'll be putting our 2. So we'd have 2. Nothing with c squared. In the middle, we'll just have 2. And lastly, we'll have 2 squared. That's a little interesting for that quadratic part, maybe. Let's go on and finish out the cubic and see what happens with this here. So the first one is just going to be c plus 2. And the second part, well, we'll have c squared, which is c squared, minus c times 2 is 2c, plus 4. Okay, that does seem kind of interesting. Why is that second part of that sum of perfect cubes kind of interesting? Yes, it is the same as the denominator over here. Now, I did mention this when we went over it last week. Actually, it's been 2 weeks now. That the cubic or the quadratic part of the sum or difference of perfect cubes does not have real solutions. No matter what it works out, it will not have real solutions. So that means that this part is not factorable. Even if y'all didn't remember that, those already match up, yes? So even if it did factor it, do I have any real need to factor this here? No, because these here already match up. They're already going to be the same, so why factor it? We'll leave it alone. So over here, we can just leave this as c squared minus 2c plus 4, and we'll bring it down here. We don't need to do anything to it because they already will match up when we do the multiplication, so we don't have to do anything to simplify it. All right. Which one do we want to look at next? The one with c to the 6th or the one with c to the 5th as its starting term? Well, have we covered one that we had to factor with c to the 5th or c to the 6th in it, or a 5th or 6th power? No. Well, we can start off with the one with c to the 6th as its starting term. Now, whenever we factor these here, what did we always start out with? A greatest common factor, yes? Is there a greatest common factor? It'd be c to the what? 4th, because all of them have at least 4, yes? Because 6 has more than 4, 5 has more than 4, and the last one has exactly 4. So if I pull c to the 4th, 4 of them out of each one of these here, well, c to the 6th will become c squared minus 4c plus 4. Well, factoring out that c to the 4th has left us with c squared minus 4c plus 4. We know how to factor that. And we can go on and do that, so, well, if it'll let me. Because we'd have our c to the 4th. in our two sets of parentheses. Since the third term is positive, the signs are the same and they match the sign of the middle term, which would be negative and negative. The factors of c squared are c and c, and the factors of 4 are 2 and 2. Okay. Any questions on this so far before we look at the last one? Well, looking at the last one here, c to the 5th minus 4c cubed is our greatest common factor. C to the 3rd. And if we factor this out, we're left with c squared minus 4. It would do that. C cubed. Well, c squared minus 4 is a difference of perfect squares, which would actually factor to what? Come on. C plus 2 and c minus 2. Any questions on this here so far? All right, so we can go on and multiply them together. If we multiply these together, on top, I move the c to the 4th up front. Because anytime we have these single terms being multiplied with these binomial, these multi-termed ones, I move the single ones up front. Then we'll have c plus 2, c minus 2, c minus 2, c squared minus 2c plus 4. And really how we organize the rest of them really doesn't matter. We just need to have them listed still. In the denominator, we'll have c cubed times c plus 2 times c minus 2 times c squared minus 2c plus 4. And we have this here. Now we need to simplify out any like terms that we have. And what would we have? Well, the c plus 2, yes, and c plus 2. We also have this massive one also, yes, the c squared minus 2c plus 4. And the c minus 2, yes. As we do have c to the 4th and c to the 3rd. Well, 3 of the ones on bottom will cancel out with 3 of the ones on top. And we do have one more left over on top. Which we will have what left over on top? C times. Or do we have anything left over on bottom? Nope. So that there would be the answer. Any questions on this here? We're going to look at one more of these here and 2 more after it. So we have 3 problems left and we are actually done for today. So we have these here. Now in the numerator of the first one, we have x cubed minus 27. X cubed is a perfect cube, so hopefully 27 is. And it is. Because the cubed root of x cubed is x, and the cubed root of 27 is 3. So this is a difference of perfect cubes. Smaller set of parentheses and our bigger one. Now our signs for this here are going to be the same. opposite always end on a positive note. Now we can plug the factors in, because for the first one, we're going to be plugging in our x. So we'd have x. In the first spot here, we're going to have x squared, x, and then x to the 0, which would just be 1. And then next we can plug in the 3. So here we would have 3, nothing. In the middle, we would just have 3 to the first. And lastly, we're going to have 3 squared. I have a feeling that y'all might want to finish out the cube before we start messing with the rest of them. And we can do that. We can come down here and say x minus 3, close parenthesis, open parenthesis. Our x squared is going to be, well, x squared plus 3 times x is 3x, and 3 squared is 9. You don't. If you want to go on and do the other factors as well, that's perfectly fine. As if we wanted to go on and do most likely the greatest common factor for these two here, and then factoring the last one, that's perfectly fine. You don't have to do it one step at a time, or each one all the way through. But it does tell us that these two here are the same, yes? So we actually aren't going to need to factor this, and well, it actually works out that that's not factorable anyways. So even if we wanted to try to factor it, we couldn't. Now, which one do we want to tackle next? The one starting with x to the 4th or the one starting with x to the 5th? Okay, if we look at the one starting with x to the 5th, well, it'd be good to start out with the greatest common factor. And the greatest common factor here is x to the 3rd, which we can factor out of each of these terms. If we factor an x to the 3rd out of x to the 5th, we would be left with x squared minus 6x plus 9. Now we could finish that out, or we can come over here to x to the 4th minus 9x squared and see if there is a greatest common factor between these two here, which is x squared. And if we factor it out, we're left with x squared minus 9. Now in the numerator here, we'll still have the x cubed. 2 sets of parentheses. Since the third term inside the parentheses is positive, the signs are the same and they match the sign of the middle term, which is negative. So we would have negative and negative. The factors of x squared are going to be x and x. Now we do have two different sets of factors for 9. We have 1 and 9 or 3 and 3. Which one would we use? 3 and 3. And if we did check it, we would get a negative 6x for the middle term with x minus 3 and x minus 3. Lastly, we need to factor the x squared minus 9. Well, we do know what it factors to, which would be x plus 3 and x minus 3, because it is the difference of perfect squares, which would factor down like this here. Any questions on this here before we multiply it together? Now, if we multiply all this together, on top we would have x cubed times x minus 3 times x minus 3 times x minus 3 times x squared plus 3x plus 9. On bottom, we're going to have x squared times x plus 3 times x minus 3 times x squared plus 3x plus 9. And if we look at these two here, we do have that quadratic in common in both, the x squared plus 3x plus 9. What else do we have? X minus 3 and x minus 3. These two will take out 2 on top, leaving us with just 1 on top. Is there anything else in common? No. So on top, we're left with x times x minus 3 times x minus 3 all over x plus 3. And that there would be our final answer. Any other questions on this here? These here are the last two types that we're going to look at. And the only thing that's really different from this one here than the ones we did before is, well, our second term isn't written as a fraction. But what is the x squared plus 3x plus 9 going to be multiplied by? The x plus 2. Because the denominator for the second part is what? 1. Because whenever we multiply a whole number or a term without a written denominator, it only multiplies with the numerator of the fraction. So sometimes it might be helpful to write in the denominator for it as 1, so we have a reminder of how this multiplies. Now we multiply these here. Well, we know that this is going to be 1. The numerator over here is still going to be x plus 2, because we do have two terms. The degree is 1, and they do not have a greatest common factor between them. So there's nothing else we can do with it here. Now the denominator for this is a difference of perfect cubes, because x cubed is a perfect cube. And if we did take the cubed root of it, we would get x. And if we took the cubed root of 27, we would get 3. So, and here we would have a small and a big. And our signs are going to be the same, opposite, always end on a positive note. So we would have minus, plus, and plus. Now if I plug the first set of terms in, the x, well, we would have x, and this here would be x squared and x. Our second set of terms would be our 3, nothing, and what are we expecting this to turn out to be? Yeah, x squared plus 2x plus 9, the same as the numerator. So, most likely, I'm going to leave this here alone. And if we do simplify that down, we would have x plus 2 here. We would have x minus 3 times x squared plus 3x plus 9. So it does work out that these are the exact same, yes? I'm going to put parentheses around them. Now, what we would do next, is we would rewrite them with them multiplied together, yes? The tops multiply with the tops, the bottoms multiply with the bottoms. Well, okay, now they're all on 1, yes? And what's going to cancel out? X squared plus 3x plus 9. Because, we can join them, really, that's all we were doing. We were just putting them next to each other, just taking the space out. So really, what's left over? X plus 2 over x minus 3. And we would have this here. Now, the textbook would say that just if we're looking for the restrictions for this here, we'd only have to list the ones that were actually eliminated. We don't have to list the ones that weren't. So the x minus 3, its restriction of 3, because if x is 3 for that part, it would make the denominator 0. We wouldn't have to list. So we'd only have to really list the restriction for x squared plus 3x plus 9. 1 times, well, what is 1 times x minus 3? Yeah, because 1 times anything is just whatever we're multiplying it by. So we don't have to include it. Does that make sense? Okay. Now with the x squared plus 3x plus 9, well, we already said it doesn't factor because it doesn't have real solutions. So is there any way that we could actually make this be 0? No, it doesn't have real solutions. It cannot have an actual 0. So there aren't any. So that would be it. Questions on this here? All right. We'll look at this one here, and then we will be finished with these note sheets here. Well, we know that this here is going to have a denominator of 1 because if it doesn't have 1, it's understood to be 1. The x minus 7 is as simplified as it gets. And we're hoping that the x squared minus 2x plus 4 won't factor because it will be the quadratic part of the difference of perfect, or the sum of perfect cubes here. Now for the x cubed plus 8, well, the cubed root of x to the third would be x, and the cubed root of 8 would be 2. So we do factor this here. Our signs would be the same, opposite, always end on a positive note. So for the quadratic part, the signs do match up. And if we plug in our terms, well, we would have x. This here would be x squared, x, and nothing in the last part. Our other number is 2. The middle term would be really 2 times x, which would be our 2x. And the last one is 2 squared, which is 4, which will match up with our x squared minus 2x plus 4. So those would be the exact same. And if we multiply these together, the only thing that's in common on top and bottom is the quadratic part, which will leave us with what? X minus 7 over x plus 2. And that there would be the answer. Any questions on this here? So that's all we are doing for today. And your homework is going to be on page 384, 4 through 7. 12 through 15, 17, 19, and 20.